Tonight's talk is going to be just kind of like an intro to using Python and interacting with this thing you may have heard of, Kubernetes, k8s, all the same thing. Basically, we're not going to go into an in-depth discussion about what it is, but this should just give you kind of like some of the trials and tribulations if you're getting started trying to interact with the Kubernetes cluster using the Python client. So just a little bit of background about me. I'm a senior DevOps engineer at Rally Health. We have open recs. If you want to contact me, you can use nathanielrock@rallyhealth.com or my LinkedIn/rockhouse. I'm always up to discuss and help people out. We'll have links to both the slides and the code that we're using for this entire presentation available at the Chippy website. So this is just kind of like a pictogram of my history. I was an Eagle Scout, lived in the woods during the summer. Worked in K-12 for about a decade, worked in the stock market for about 8 years, and now I basically work at Rally Health doing Kubernetes-based things full time. In that line of work, my daily grind basically currently is to take a bunch of apps across the company that are in a Mesos cluster. It's basically just another container orchestrator. Hundreds of devs, thousands of apps, take them and migrate them from running in the Mesos world and facilitate teams to be able to run those same apps in Kubernetes. There's some differences between the two. We're not going to kind of get into the details of that. But in this process, our ops team has created a tool called Dr. Pickle. Dr. Pickle is namesaked after an individual on the ops team named Parker, aka Pickle. And we've just taken his knowledge of Kubernetes and Mesos and just codified it. So Dr. Pickle knows how to talk to Mesos, knows how to talk to Kubernetes, can do things like version compares. And this is the primary focus of tonight's talk. So this is just an example. So in Mesos, you might have an app that's running on the Marathon versions endpoint that gives you a version of an app called k8s Wrangler 1.14.0. And then that same containerized app running in the Kubernetes cluster should also return the same simple JSON format with the name of an application and a version. This is pretty useful as your teams migrate containers in bulk between different environments in Mesos and Kubernetes, and also because we are splitting out and giving each team their own Kubernetes cluster, you now go from kind of a monolithic giant Mesos environment to multiple different Kubernetes environments. So tracking where things are and how they've been migrated is pretty essential. And this kind of goes through some details on some of the techniques we use to create Dr. Pickle. Doesn't have the exact Dr. Pickle code, but all of the techniques you'll see here are used in that tool. So I don't like to talk a lot, but I do like demoing stuff. So on to the demo. Here is a link to the source code for tonight's thing. It will cover how to use Minikube with Kubernetes. We're going to be using two different versions of Kubernetes, version 1.14 and 1.16. Those are not chosen by random. Those are chosen for a very specific reason. And we'll go through a couple different scenarios. The first one is we'll be running our little Kubernetes version app, our k8s Wrangler, locally off the machine, as you might do if you're just developing and want to do debugging locally. You will see it works pretty well. We can hit the REST endpoints, we can get pods, and we can get deployments. The second part of the demo will be running the same application that's been Dockerized and running inside of the Kubernetes version 1.14. This is kind of important because up until I think last week or a week before that, a couple weeks, EKS, which is Amazon's Kubernetes offering, only supported up to 1.14 and 1.15. I don't believe they had support for 1.16. However, as we're going to show, going between versions 1.14 of Kubernetes and 1.16 of Kubernetes, if you're coding against it, there's some tricky things you need to pay attention to, because as their APIs evolve from beta to being adopted into the full spec, you've got to deal with some problems. And we'll kind of outline that and show you some examples of that. All right, let's jump into some of the code and some of the demos here. So we'll start out with the code. Basically, you've got your simple Flask application here. We've got two endpoints, deployments, and pods. They're just gets. We've got this k8s Wrangler object that knows how to talk to Kubernetes, knows how to get a list of deployments, knows how to get a list of pods, and output it as a simple JSON. And so we can just take a look at the code for the k8s Wrangler here quickly. Nothing too crazy. It's got an initializer, it's got a get pods function, a get deployments function, and just like a simple main. So if you're debugging locally, you could run this without having to hit the web endpoints. There's also some testing built into this service, or into this repo, but we're not going to get into that for now. All right, so let's clear this out. This is the first scenario. So if we go here, we set it up. This is using a requirements file and virtual environments. So there's documentation in the README. We're just going to skip ahead through that, assume you've got it set up and ready to go. So we're excited, and we're going to run our app, our Flask application. You notice it's up and running. It's listening on port 5000. We can do some very simple curl commands here to just verify that it's working. Let's hit the pods, pass the jQuery. Ta-da! It's showing that there is a K8s Wrangler version 1.14 running in the Kubernetes cluster we're attached to. And we can do the same thing for the deployments. Ta-da! Everything's working magically. We're like, awesome. Our code's great. Our Python code knows how to talk to Kubernetes. Let's take this, Dockerize it, and put it into a Kubernetes cluster. So luckily for you, we have all of the code that you need to do that inside of this project as well. So part of this is we've got our Docker file here. It's based off Python 3.7 Slim, copies requirements. We'll get to this in a little bit. We've installed Git actually for a very specific reason. And then we basically call our app just like we did locally, and it's listening on port 5000. So for those of you who are not familiar with Kubernetes, we'll just take a look at kind of the deployment file here. It's got some more than just the deployments in it, but it's good to go over. And so here we've got the namespace. We're explicitly installing this into the Chippy namespace for this project. So we're going to take our app, put it in the Chippy namespace. So we create our namespace, and then here's the deployment. Nothing too crazy. It's named K8s Wrangler. We want 2 of these things running so we can do load balancing. And here is the key thing. This is the Docker image that we have built. And if we'd like to see in our Minikube Docker registry, we can do Docker image ls Wrangler, and you'll notice, we'll just switch to the 1.4. And you can see that in this particular Kubernetes cluster, I have these 2 versions of this app running, a 1.14 version and a 1.16. We are going to be deploying the 1.14. So we stop our web application here because we don't need it. We're doing Kubernetes stuff at this point. Very simple way to deploy it. kubectl apply our deployment file. And so it's going to do some stuff. You'll notice it's unchanged. I deployed it before this, but we have a namespace Chippy and a K8s Wrangler app that has been deployed, which is also unchanged. To double check, you can use kubectl like git pods. Get pods -n for Chippy. And you'll notice we have 2 pods running. So our deployment said we want 2 of them running. It's got 2 of them running. We're ready. We're ready to go. Now I'm just going to showcase another tool because we're going to be referencing it again. I like this view a little bit better, especially if you're new to Kubernetes. This is called Lens. It uses the same deployment files that the command line does. So if you can do those kubectl commands, you can use Lens. And for now, we can just verify if we select our unselect default, select Chippy. You'll notice that we have our 2 pods running here. They look green. Things are cool. We can click on it. We can look at the logs. However, we can see when we click on these logs, there's this forbidden message in here. Maybe this is left over from what I was doing before. And so I basically want to be able to connect to this app and just test it out in the browser. I don't know where my browser. Oh, here's my browser. So we come to the web browser. We can get the endpoint inside of Minikube by using Minikube service command. Again, all of this will be documented in the README so that you can just look at the commands that we've been using here. But if I try to attach to that, it will open up the web browser. The root doesn't have it, but the pods does. Man, we're supposed to be getting an app and a version in here. what's going on? It's returning an empty JSON. And again, if we come back here and take a look at these logs, we can see, yeah, there's this forbidden here. Well, if you take your app that you've been running locally and just put it in Kubernetes, and you're trying to talk to the Kubernetes APIs, you're locked out. You basically, it doesn't let you just have access to hit the APIs internally. It uses a mechanism called role-based access control, which you might have heard, which is RBAC. And to solve this particular problem, we just basically need to add a little bit more Kubernetes sauce. So this is the second scenario. We've taken our app that worked perfectly well locally, that we had access and all the rights we needed to talk to the cluster. We've put it in our Kubernetes cluster, and it's failing with an access right. So to take care of that, we have a second deployment file called deployment RBAC. You'll notice it's got the same thing, the namespace at the top, but below that, it has a couple new sections. It's got this authorization that will give our K8s Wrangler read-only access to this, and it has this chunk here that is going to give us access to the extensions API for the deployment resource, and it will allow us to list it. We also have one for the pods that will allow us to list the pods. So you'll notice we've got different resources. We've given different access to them. This will become important as we go between 1.14 and 1.16. You can kind of see this code commented out here, but we'll get to that in a little bit. And then once we've created that, that we've basically assigned it a service account, so that's internal to the cluster. And we say, hey, in the Chippy namespace, the app that is named K8s Wrangler has access to do this. So here we are at this point. So if we go back to our code here, we can do our kubectl apply again. And instead of doing the standard deployment, we can do the role-based access control. And you'll notice here it's created, it's taken what we've gotten, we've given allowance to be able to do it. And now if we go back to our browser and take a look, ta-da, we are able to hit Kubernetes. We've given our app access to be able to read only those things. It's able to communicate using the Kubernetes Python library, and we can just double check deployments. And again, sweet. So this all looks good. Phase one is complete. We're now through the first two scenarios. It worked locally. We needed to do a little bit of extra stuff to allow it to actually run inside of the Kubernetes cluster itself. And now let's say, management says we need to be on the latest and greatest, stable version, or at least 2 behind whatever the current version of Kubernetes is. Current version is 1.18. And we're like, cool, let's take our app. We know it works in 1.14. Let's deploy that same application to our Kubernetes 1.16 cluster. And so we can just switch on over to that. 1.16, we will do our, apply our hardened RBAC things to the cluster. We can go back to our Lens application and just validate that our secondary cluster has the services. You'll notice it says Kubernetes 1.16. We check our pods. We got 2 of them. They're green. We've got some logs. Cool. It's listening on port 5000. We're gold. We are good to go. And so we're actually going to expose this. Whoops. Expose the K8s Wrangler on port 5000. Oh, it already exists. So I was busy testing before. This should already be here. And we can do our Minikube service 1.16. So we're connecting to the Kubernetes 16 cluster instead. Do it. We open it up. We hit our pods. Bam. We're gold, right? Everything works fine. We're able to hit our pods endpoint, no problem, same exact code. Now, here's where we get into a little bit of trouble. And this is the third scenario that you should be aware of if you're using Kubernetes or Python to talk to Kubernetes. If we try to hit the deployments, oh man, we're back to our empty list. Instead of throwing an error, I'm just returning an empty list. But if we go back and take a look in the cluster in our lens window here, let's just hit that a couple times because it's load balanced. You never know which one's going to hit. Man, you know what? It's not found. So in this particular instance, between version 1.14 of Kubernetes and 1.16, your code that worked on 1.14 will not work with a newer version of 1.16. Why is this? Well, all of the Kubernetes APIs, something you should be aware of, go through like a beta adoption process and then get adopted back into the main. And as they do that, they go from one named API subset to another. And so in this particular instance, getting a list of pods didn't change. It's the same. It's all core V1 API endpoints. But deployments go from V1 beta 1 to apps V1. So it was graduated from a beta status to a GA status and merged in. And that's what happened between 1.14 and 1.16. We can very easily take a look at the pieces of code we need to change to get this to work. We start with our requirements file. Remember before when I was doing, or we'll actually start at the Docker file. The Docker file for 1.16, I need to install Git. Why do I need to install Git? Well, it turns out they haven't built an official PyPy or cut of the version 12 of this library yet. And so the only way to get this functionality is to actually get it directly from GitHub. So here is a nice way for you to be able to do that. I didn't even really know you could do this, but it was something we needed to do to make this work. So the current code and master for this Kubernetes client will allow us to do it. We use GitHub. We build our Docker file after installing Git. And I've already done all this. It takes a little bit of time. But again, if we do, we switch over to our Kubernetes 16 cluster and do Docker image list Wrangler, you'll notice we got this 1.16. This image was built off of that. You'll notice it's about 100 megs bigger because it has Git installed on it. Boo. So those are two pieces of code that we needed to change. We also needed to actually go through and change the code itself inside of the Kubernetes cluster. We'll just go through this real quick. There are two spots we needed to change it. In the constructor here, in the init, you'll notice here's this extension's V1 beta 1. We are no longer using that API to connect to it. We're using apps V1, so now it's GA. And then we also have, under the deployment section, instead of us getting the list of deployments using the beta version of the API, we're using this version of the API. So that's basically the changes that we needed to do to make it work in 1.116. So now if we change our Kubernetes deployment file to use that version of the application that knows how to talk this API, we can deploy it. And we'll just redeploy that. You'll notice it changed the app version. And if we're fast enough, we can go back and see the lens here. And you'll notice it's, here's some stuff that's been up for 5 minutes. Here's some stuff that's been up for under a minute. These are our new services. We can see they're listening on 5,000. We go back to our web browser. Boom. Wait a second. It's not working. We have the new code. We knows how to talk to Kubernetes. Remember how that role-based access control came and bit us before? It didn't let us access it. Well, if we go back and look at that file, we actually gave it access to the old API endpoint. So we need to adjust it to be able to give you access to the new API. In fact, let me hit this a couple times so just we can be sure we got the forbidden. In fact, we've got the forbidden. We're not forbidden to hit that old beta API. Or we're forbidden from hitting the new version 1 API. We were able to hit the old beta version. So we can just go to our role-based access controls, and we're going from the old version to the new version under apps. And we go and we reapply that. And you'll notice this on this line, we have updated the role for this particular service. And boom, we are now able to do it. So really, in this example in this set of code is I find is pretty useful for people who are getting or who are interested in learning Kubernetes, or interested in learning some simple Python stuff, and kind of showcase two of the major hurdles we ran into while creating the Dr. Pickle application as we migrated between different versions of Kubernetes and had this app that was running in Mesos also be able to run inside of the Kubernetes cluster with security rights, with role-based access control. With that, I think I am done. I'm open for any questions if people have them at this point. So what do we have? We've got live stream available later. The stream is being recorded, and a bunch of unicorns. Does if anyone has any questions about this or anything, feel free to post them in the chat. I'll be happy to answer them at this point.
So I think Google is having some technical difficulties, but this we are still recording. So I'm going to ask a quick question: like, how would you, or what have you found that works for automating like the kind of iteration on like building and deploying different Kubernetes resources?
For now, it's just been source managed control. Like I said, up until recently, version 1.116 hasn't been available. So all of the code that we had written that worked with 14 also worked with 15. And then just recently, we spun up a test cluster with the new k8s version, the Amazon Kubernetes cluster, and tested this app. And lo and behold, couldn't find the API. And so part of that investigation was looking through here. Had we been closely following the Kubernetes changes, if you go to the Kubernetes documentation for 1.116, it explicitly says the ability to list deployments has been moved from beta status to GA, and the previously deprecated beta version has been completely removed. But when you're using just the standard Kubernetes commands, like the kubectl commands, your commands don't change between versions, but it's all hidden from you inside of their Kubernetes client, because they know the changes and have migrated it forward. The same goes with Lens. Lens is pretty good about detecting the versions. You could very well, just as you get the versions, look at the release logs and notify yourself. We've actually had discussions about this because of these types of issues, so it kind of broached them inside a rally when we were discussing what would happen if we upgraded a new one and we just deployed this, and I'm like, it would break. So being able to monitor the release notes and just kind of compare what you have inside of your Kubernetes deployments and your apps versus what is available to that version is definitely something you want to keep up on if you are coding directly against the APIs in something like Python or Go.
Let's see, do we have any other questions? I thought I saw one pop up. So Ray asked on ChippyTube. I've heard about some tools to aid testing, validating k8s configuration. Any recommendations on technologies for applying software processes to k8s configuration?
Not directly. The way we actually interact with Kubernetes at Rally, we actually have an intermediary layer that generates all the Kubernetes configurations for us. But like I said, we have broached the subject before because of issues like this, where you have a major component that you're using, like deployment, very key. Every single app we deploy uses that, and it's now gone from one API to another API. I think we have some discovery tickets as we prepare up for actually getting 1.116 in prod. If anyone has heard of any tools, feel free to share them. I'd be glad to take a look and evaluate them, because that is a great question.
And we have a question from Ali Sivji. So how do you set up migrations for a web app in Kubernetes?
Set up migrations.
Database migrations.
Like database migrations. That's outside of the scope of this, but it's just like you do it with any other containerized or Dockerized solution. As you're rolling out your versions, you just need to be very careful about which apps are up and running based off of the schemas. Have a solid rollback plan.
So do you use like a Kubernetes job or like some other one-off process, or?
it's up to the individual dev teams. At Rally, we've got dozens of them. And so each one has their own, some of them might be doing Ruby, some of them might be doing Python, some of them might be doing, Scala or whatever. So it's really up to them to handle their evolutions or their migrations on their app level. On the ops team, we're not really in charge of that. But I don't think it's necessarily a Kubernetes specific question. It's more, how would you manage your migrations in anything where you could potentially have a period of time at which some apps are not in sync with the underlying database structures.
And we have one more question from Rayberg. Yeah. Is there a way to store your Kubernetes configuration as code?
Yes, in fact, that is 100% what I've done here. In fact, you can see this. It's checked in the repository. It's versioned. You can modify it. You can PR it. You can evaluate it. Other people at the company can do so as well. So this file right here is literally what I sent up to Kubernetes to deploy these applications.
Cool. Well, thank you very much for your talk. That was Kubernetes is a really cool piece of technology, and thanks for walking us through it.
Yeah, not a problem. It was kind of a wham bam laser show, quick run through Kubernetes. I kind of glossed over Kubernetes side of it, but if you're interested in getting started with it, I would definitely take a look at the repo, because you should be able to tinker with it just like we did here in a very simple manner and have some of the security rights and other issues that we ran into at your fingertips to play around with.
Great. We'll post the link to that repo in the comments or in the description for the YouTube video.
Perfect. Thank you.